Class 12th Subject Chemistry Chapter 4 Lecture 1 Surface Chemistry. So first of all we will define what is surface. So surface is the topmost layer of anything. For example, if we want to define the surface for this liquid B which is filled in this container, so this topmost layer, this will define the surface. So in surface chemistry, we will deal with the phenomena that occurs at surface. So from here we can define surface chemistry. That is, surface chemistry is that branch of chemistry which deals with the phenomena that occur at the surface or interface. So the next thing is, what is interface? So interface is the boundary that separates two bulk phases. For example, if we have oil and water, which is a mixture of liquid and liquid, but as we all know that oil and water do not mix, therefore the thin line that separates oil and water, that defines the interface, and interface is represented by hyphen or slash. Now when we come to gases, so in case of gases no interface exists because gases are completely mixed with each other. Therefore, there is no interface between the gaseous molecule. In this unit, we will do some important features of surface chemistry, which includes adsorption, colloids, catalysis. Now, we will do all these three one by one in detail. So, first of all, we need to understand what is adsorption. Adsorption is the phenomena of attracting and retaining the molecules of a substance on the surface of a liquid or solid, resulting into the higher concentration of molecules on the surface. That is known as adsorption. For example, silica gel, which is solid, when placed in a closed vessel containing moist air, after some time that air will become dry. That is because air molecules are adsorbed on the surface of silica gel. Second example is, if we have a closed container and O2 and N2 is filled and the pressure is measured and the value comes out to be, let's say, P1. Now a piece of charcoal is placed in this closed container and the pressure is again measured. That will comes out to be P2. Now the observation is that P2 is less than P1. From here we can conclude that some amount of gases are adsorbed on the surface of this charcoal. We have one more example, that is, if we place raw sugar in animal charcoal, as raw sugar is yellowish brown in color. So when we put raw sugar in animal charcoal, that raw sugar converts to white crystals as the yellow stuff which is present in raw sugar is adsorbed by the animal charcoal. Next term is absorption. So absorption is a bulk phenomenon and it is passing of substance through the surface into the bulk of liquid or the solid. What are the differences between absorption and adsorption? So the first difference is absorption is a bulk phenomena whereas adsorption is a surface phenomena. Next difference is absorption occurs at a uniform rate whereas adsorptions it is rapid in the beginning and then decreasing, because in starting all the surface is available and once the surface is occupied, therefore the rate of adsorption starts decreasing. Third difference is, in absorption the concentration is same throughout the material, whereas in adsorption the concentration is more on the surface, because adsorption is a surface phenomena, therefore the concentration of molecules will be higher at the surface. Fourth is, anhydrous CaCl2 absorb water vapor is the example of absorption, whereas if we take silica gel instead of anhydrous CaCl2, that is anhydrous calcium chloride, then the silica gel it will absorb water vapors. So these are the differences between absorption and adsorption. We have few more terms, that is sorption, desorptions and occlusion. So one by one we will discuss these three terms. So first term is sorption. Sorption is when both adsorption and absorption takes place simultaneously. That term is known as sorption. Next is desorption. So adsorption is the process of attracting or retaining the molecules on the surface of liquid or solid. Similarly, desorption is removal of adsorbed substance from the surface, that is known as desorption. Third term is occlusion. It is adsorption of gases on the surface of metal, that is known as occlusion. So these are the terms which are used in adsorption. Now we will discuss the mechanism of adsorption. Now we will discuss the factors affecting adsorption of gases by solids. So here gases are adsorbate and solids are adsorbent. So first factor is nature and surface area of adsorbent. It is observed that same gas is adsorbed to different extent by different solid at the same temperature. It is also expected that greater is the surface area of adsorbent, greater is the volume of gas adsorbed. That is why charcoal and silica gel, they act as excellent adsorbent because of porous structure and large surface area. Second is nature of gas. So, different gases are adsorbed to different extent by the same adsorbent at the same temperature. If we relate the nature of gas to the critical temperature, that is, higher the critical temperature of a gas, more easily the gas can be liquefied, or we can say that greater are the intermolecular forces of attraction between the gases which have higher critical temperature. For example, critical temperature of N2 gas is 126 Kelvin and critical temperature of CO is 134 Kelvin. So higher the critical temperature, more easily the gas can be liquefied and thus adsorption will be more for that gas. So if we compare the adsorption of N2 and CO, so critical temperature of CO is more, it means the adsorption of CO is more on adsorbent as compared to N2. Third factor is pressure. Now as we increase the pressure, greater will be the forces of attraction between the adsorbate and adsorbent, and therefore adsorption will increase. That is, adsorption of a gas increases with increase of pressure. Now fourth factor is temperature. Adsorption decreases with increase in temperature. We can explain this on the basis that as we know that there are force of attraction between adsorbate and adsorbent molecules. So when the temperature is raised, the force of attraction between the adsorbate and adsorbent that will decrease, and therefore the adsorption will decrease. Fifth factor is activation of solid adsorbent. That is, the activation is done either by increasing the surface area or by making the surface rough. So we can activate the solid adsorbent by dividing the adsorbent into smaller pieces. That is why, because on dividing the adsorbent into smaller pieces, we can increase the surface area, and if the surface area increases, obviously the adsorption will increase. We can also remove the gases which are already adsorbed on the adsorbent. For example, charcoal, which is a solid adsorbent, it can be activated in vacuum at high temperature, that is under 623 to 1273 Kelvin. This charcoal can be activated and therefore the adsorption will increase with the activation of adsorbent. So these are the factors affecting the adsorption of solid. So these are the 5 factors which affect the adsorption of gases by solids. Now after studying this lecture, you can solve NCERT exercise question number 5.1 to 5.4, question number 5.8 and question number 5.10. So this is the homework for today's class.